Hey class, how's it going? We got projectiles from ground level, kind of part 2 here. I'm going to be working on practice questions 8 and 10 from worksheet number 2. So I think on that worksheet the first 4 or 5 are just horizontal questions, and then it goes in like type 2 quick questions. Those are now the ones with angles, so questions 6 to 10, 5 to 10, something like that. I'm going to be doing questions 8 and 10 from that second worksheet. So let's go through it. Let's see how we got for some questions. I gotta do this first. There we go. And then pop this up there. Beautiful. All right, I know the writing is really small. I'm gonna draw it out and tell you what it's all talking about here. It says a ball is thrown with a velocity of 24 meters per second at an angle of 30. So again, we have this. Ball's thrown. Okay, angle of 30 degrees. And the velocity initial is 24 meters per second. Awesome. Okay, and again. It'll look something like this. I'm going to put this right here right now. We're always, I shouldn't say always, but basically every single time we're going to split it up at that max height point to give us all of our stuff. First thing it says, what are our vertical and our horizontal components? So let's do our Vy and our Vx. Should be pretty easy by now to get your Vx. Cos of 30 times 24 to get a Vy. Sine of 30 times 24. So I think I get 20.8. 20.8, and then 12 here. All right, how long is the ball in the air? I'm going to get my time to the halfway mark. Because this is just a nice parabola, whatever time I get there, I will get the exact, like doubled for the total time. Okay? All right, so now that I have these, okay, I know that my Vy up here is 0. Okay, my Vy at the top is 0, which is what enables us to make this question kind of easier. So I have my velocity initial in the y direction, which is 12. I know my velocity final, and I know gravity is working against me. So it's going to look like this. We're going to have this equals, this is the formula that I'm going to use. And let's plug in some numbers here. Negative 9.8 equals 0 minus 12 over time. That's what I want. And then you end up getting this. Time equals negative 12 over negative 9.8. Which gives you 1.22. Now that is just the time. That is just the time to the top here. Time 1.22. All right, so that's just our max height time. If I want total time equals 2.44. Just double that. Okay? Because again, whatever happens in the first half for time-wise, be exactly the same as the second half. So there's our total time. How far away, so I'm looking for this now, how far away will the ball land? I need my dx, this little landing spot here. This is quite easy again in our x direction. Our velocity is constant. So we can use that d equals t, distance equals time multiplied by velocity formula. I have my time now. I know my velocity in the x direction, so this should be pretty easy. Distance equals t multiplied by v, which is 2.44 times 20.8. And my distance, I should get something like 50.7 meters. Yeah, 50.7 meters is how far away it landed. All right, what is the max height? What is the max height the ball rise? The nice thing is, like, you have a Vy here, you have a Vy there, you have the time now. You have a lot of things. You could use a lot of formulas. You could use this one. Okay, as long as you're using just your y components. You can use your Vy, like 12 there, negative 9.8, you have your time now. You could use this formula. You have Vf and Vy in the y direction, so this would be 0, this would be 12. I just like using this formula. It's simple to find, like once I actually have that time, I like just using this formula for that one. I don't know why, I just do. So distance in the y direction. Okay, my Vi is 12 plus 0 at the top, divided by 2, and I know my time is 1.22. I'm using my time of the max point, because that's what I care about, the max height here. All right, so this ends up being 6 times 1.22, which gives me 7.3 meters. So this height was 7.33 meters. Okay, so the max height that it got to was 7.33 meters. All right, last question that's really small at the bottom, it's hard to see. With what velocity will the ball land? Okay, and again, you could try and find the Vx and the Vy right here. The Vx is always 20.8. This Vy was 12 at the start, And the nice thing is it's going to be 12 exactly, because again, just the nice symmetry, the nice parabola. If it's an exact parabola and there's no elevated distance, the velocity is going to be exactly the same. Okay, so I don't even need to do any work here. I'm just going to put 24 meters per second at an angle of 30 degrees. All right. If you wanted to go through this and figure it out again physics-wise, like I did in an earlier question, you have the distance now of 7.3. You know the time. You could figure out everything that you wanted to get the Vy, the new Vy. When you do calculate it, it'll give you 12. And then you go 12 squared plus 20.8 squared, and then it'll give you 24. So it'll give you the same answer, okay? Now, when we actually have an elevated height and we have extra distance that's going to fall, that's when we for sure need to actually find those two different, like that new Vy. The Vx is the same, we'll have to find a new Vy. That'll be for next time. All right, that's question 8. Let's go to question 10. Answer that one. Let's make this a little bigger. All right, let's bring this over. Too far. There we go. Good. All right. So let's erase this. Let's bring this up a little. All right, perfect. So another, like basically something from the ground being thrown. Let's figure some stuff out here. It says, on level ground, a football is thrown with a velocity of, it doesn't say. All right, the ball is in the air for 2 seconds. So we have total time of 2 seconds. Okay, and it gives me the total distance. This dx equals 30. All right, I'm going to put a line there. I always put a line there. That's my max middle point. It says, what was the ball's initial velocity? So to figure out the initial velocity, not only do I need an actual like magnitude, I also need the direction. This seems like it could be tough, but again, think about it. I need a Vx and I need a Vy, and then I can put them together with vectors. All right, the Vx hopefully should be pretty easy, because if you think about it, we only really use this formula for the x direction, which is basically just distance equals times velocity, because it's a constant thing. And the nice thing is we have our total time, and we have our total distance in the x direction. So if I just go with distance equals time my total velocity, and we read this just for now, I have 30 equals 2 times v. So velocity equals 15 meters per second. That is in the x direction. All right, so I got 1. Got my Vx now. How do I figure my Vy? Well, let's again split it in the middle. What happens at the max height? Well, if this is an exact parabola, which it is, I know that my time will be half it. So my time right here will be 1 second. I also know that my Vy right here will be 0. Because it's again, at the very top max height, my Vy is 0. I can use these two, the time and the Vy, and I know that my acceleration is still going to be 9.8. I can use those to figure out what my initial is. Anytime you have a time, here you can figure out how, like what your actual initial velocity was. And so, at least in the y direction. And so let's do that. Again, we can use this formula right here now. We have our acceleration, we have our final, which is 0, and we know the time. So in our y direction, we're going to have 9.8, okay, equals, our final is 0, it's going to be negative 9.8, just because it's going against you, minus Vi, I don't know, and time is 1. We can ignore the 0. If I multiply by 1, cancel it, multiply by 1. Again, my Vi becomes 9.8. So nicely, my Vy, 9.8. Cool. So I have this 15, I have this 9.8. I'm just going to draw it out to hopefully make sense to you guys. That means that in this direction, it's going 15. In this direction, it's going 9.8. And now look, we have our vector questions to figure out our actual initial velocity. Okay? Technically, that 9.8 should be going up. Now that I look at that, if I do this, technically it's the velocity here. Nonetheless, it's 15 and 9.8. If you go 15 squared plus 9.8 squared, and then square root it, you get an answer of 17.9. So 17.9 meters per second at, again, to get this angle, you're just going to go like inverse tan of y over x. So your y, 9.8 over 15. Use that decimal, put it into your inverse 10, you get 33 degrees. Okay? So there's again another like on the ground question. It always helps us to break up the middle. It gives us extra things. It gives us that Vy of 0. We can figure out that time. It helps us a lot. All right. Next videos will be going on to some projectiles at angles. A little tougher, but you guys got this. No problem. All right. I have to do this. And I shall talk to you guys next time. Thanks.